Hello, I'm Associate Professor Hanna Suominen from the ANU and Data 61 of SARO. I live in Canberra, Australia, and it's lovely to get to know you. I'm going to tell about machine learning, so this is a brief introduction followed by some hackathon activities. In today's information society, machines may make or break a day. So information knowledge is power. Here on the left-hand side, we have a nurse who is very frustrated with her electronic health record system. And notice all of those post-it notes where she's having extra notes or instructions how to use the system to herself and so on. So that's when she's like, oh no, what should I do? The machine is making her day very challenging. On the right-hand side, we have a screen capture of a system that we have built for helping nurses to capture the shift change nursing handover discussions by using voice recording followed by speech recognition, converting that spoken narrative into 3 text notes, and then text classification or information extraction to fill out a form for the nurse so that they can proofread, revise, and save the draft in the electronic notes. Although this is a demonstration system, not in use yet, it's a nice demonstration how technology can help make human workflows more efficient and more effective, thereby releasing time to more joyful tasks from sometimes laborious and boring recording or documentation task. More widely in healthcare and in other sectors where decision making is critical and heavily based on accessibility of data, the problem is to get the right data or information at the right time to the right user. So let's consider an example. We are here in an acute care environment, in emergency, where clinicians are bringing the patient in and they are suspecting, so that's the question mark on the slide, a condition related to the patient's breathing. So pulmonary arterial hypertension is the technical term. This is an interesting term because the best practice and care guidelines keep on changing very rapidly. There's a lot of research going into the condition. So if I was a healthcare professional and I wanted to read what is the most up-to-date knowledge about the topic, I would go to my favorite web search engine called PubMed, and I would put there a search with little quotes around it, pulmonary arterial hypertension. PubMed has over 30 million publications indexed, and every single day we get thousands of new papers being added. So this search of mine, it returns over 12,000 publications, of which 2,755 are reviews. So I can restrict or limit my search, and I'm doing it only for reviews so that I can get the systematic evidence from the original studies that way. So utilizing both the human power to write the systematic reviews and then the search engine's power to find just the reviews and not the original papers. If I limit my search a little bit more, I say that I just want to get review papers that are published within the last 5 years. I still get just a little bit shy of 1,000 hits. And if I'm this clinician who has a very severely ill patient to look after, and the patient's condition is such as this one that is being suspected, where you have a couple of minutes to make the right decision, and the decisions, they can even cost the patient's life. So it's really important to make the right decision. I don't have time to start reading 1,000 reviews or just even the abstracts of them. So this is really a bottleneck, and that's what my research is mainly about. So helping healthcare professionals to gain access to information. Usually it relates to natural language processing, so free-form text. But in today's talk, we talk more widely about machine learning. So not only about text or spoken language, but also other modalities of data. We have a little bit of a history first to machine learning and the key terms and methods there. Then we have a look, how can we tackle real life problems? So it's not only about solving problems, actually the key step there is to find the right challenges to solve. And then we have a look of my recommendations for next steps to take in terms of applying the skills or knowledge from this brief introduction to practice as part of the hackathon. So, machine learning is nothing new. It was actually defined in 1950s. So at the moment, we are living a golden era or golden age of these methods. They are very popular. So one might even say that it's a hype of AI. But it's a research discipline of its own, and it has been established in 1950s already. So here are the two pioneering definitions. And notice that the applications of machine learning like computer vision and natural language processing have been there from early on already. And also certain methods like neural networks that are very popular today are there. So the key here is that instead of programming precisely the rules how to solve a problem, the point is that the machine learns how the solution is done or mapped by identifying relevant information from examples and drawing conclusions from those examples. So there's still an algorithm, there's still a method. That algorithm describes how to look at the data and how to connect the data with the desired solution. So how to predict the future or how to solve a given problem based on having a look of historical examples. So it's a little bit like when people learn language. I'm a mother of a 6-year-old and I'm constantly correcting him in the right grammar and increasing his vocabulary by reading stories to him. And it's amazing how a human brain learns this simply from the examples and corrections that we people make. And this is how machine learning AI tends to work as well. Here is a lively timeline that Dr. Elena Daskilaki from the group where I work was creating with me a little time ago. So some of the methods that are there. So basically there are two main categories, supervised machine learning task and unsupervised machine learning task. The differentiation here is if you need to have handmade, human-made examples where you have the desired outcome marked for every example. So if you have both the example and the wanted output for it, and then the learning is established by observing these two pairs, or if you use those pairs only for the evaluation. So if it's used only for evaluation, we talk about unsupervised machine learning. However, for both cases, we will need these model solutions or ground truth or reference standard, how we call them. In 1950s, the methods were around naive Bayes, artificial neural networks, genetic algorithms, perceptions, and nearest neighbors. After that, in 16s, methods like conditional random fields and hidden Markov models appeared. So these are going from individual observations to a timeline of observations. So the history, the context of what has been just before and what's going to be in the future matters in the predictions. Some unsupervised methods that I could mention are the self-organizing maps. I'm originally from Finland and I'm very proud to tell about these self-organizing maps, also known as Kohonen maps after their inventor from Finland. Autoencoders emerged then as well. In 1990s, the work was centered around supervector machines, random decision forests, gradient boosting. More generally, statistical machine learning methods are what we talk about there. Then in 2000s, deep belief networks started to appear, and from 2010, so early 2010s, roughly 2012, deep neural networks started to come big to the field, and they have really started a new era in machine learning. What I would like to emphasize in this talk is that typically we do not have the luxury of big data in when we start to work on problems. So we need to have boutique methods or methods that work well on small data instead. In particular, this is the case with supervised machine learning. So very rarely we have the luxury of having these large data set with human annotated model solutions to build our solution on. And really, where the creativity or innovation lies, it's about identifying the problem or challenge to solve, and then compose this task as a machine learning task or problem. So that's where the creativity comes to role. Then it's also about clever or smart features and the sweet feature engineering there, and choosing the right methods for the solution. And in this way, we can have a computer-assisted workflow from the initial measurements or data. So it could be the speech signal here, or it could be sensor data from a balance test, or measurements about humidity and temperature, for example. Then in the example that I had before about form filling, we would have the first machine learning task there to convert the spoken language into writing. And again, like I mentioned, one needs to have the model solutions there. So in this case, the model solution would be somebody transcribing the speech, and then we would assess how well does the machine learning solve this conversion problem from spoken signals of language to writing. After that, it's the part of choosing the machine learning methods and models for both the prediction task as well as the evaluation part. So there are two methods here, the ones that process the data and the ones that evaluate in the end how well we do. And in the end, we hopefully get customized insights. So it could be the filled out form or summarized text or decision support system or something that helps in situational awareness what's going on. I'm quite often mentioning that machine learning, it's both a science and an art. So we tend to be crafting the methods, and there's a lot of professional knowledge and insights, wisdom that goes into creating the pipelines. But thankfully, we have lots of tools available now, making learning this profession and science around data easier accessible to beginners. So there's plenty of tools, and we will have a look at them later, where to get going and where to get started. And again, I want to emphasize that this is about creativity and keeping on going, keep on going. So one needs to be really plucky there, not just lucky, but also plucky. And a dear colleague of mine once inspired this with a metaphor from another purpose, but I have applied it to machine learning as well. So this is a little bit like having a newborn baby, like mine is here in the photo. It takes so many sleepless nights and so much hard work to raise a child, but everybody's excited and everybody's happy. And that's a little bit like it is when crafting machine learning methods. It's a lot of fun, a lot of work, hard work, but it's very rewarding when one gets there. The harder the problem or challenge, usually the more satisfaction we get out of solving it. Jimmy Cliff also says it that you can get it if you really want, but you must try, and you will succeed at last. So I think that this is usually true for most of the machine learning tasks. Where solution starts and the problem identification starts is like in any software engineering project, showing empathy to real people's information needs and decision-making needs. So one needs to go there to the problem owner and have a workshop or have a discussion and try to understand their perspective. And then it's about co-designing, co-development, and co-evaluation, and usually this is around iterations. And again, I emphasize, it is doing it together with people whose decision-making or information flow workflow we are trying to support. In most of the areas where I work, in particular in healthcare, magic doesn't cut it. So I cannot just say, trust me, it works like magic. Instead of a magician's hat, I actually need to wear my doctoral hat, like in this picture, that is from one of my talks. Actor network theory or action network theory tends to tell about this, that context of interpretation and unavoidable delusion or change of meaning, that's the theoretical framework in social studies for this, by Latour. We could also say mirror, mirror on the wall, who's the fairest of them all? So machine learning tends to be a mirror. It's the mirror of the past, so the historical data we have, to the future. And all the imperfections of that data is going to be there in the future, and it's going to make a change. Very rarely the processing method and its setting is the same. What we read from, let's say, people's paper, it's very difficult to describe every single detail that is needed there for getting exactly the same solution as what the scientists originally made. And we scientists, we are also trained to describe our work, tell narratives, tell stories about our work that are engaging. And it's not usually having every single detail there. The same about the data and its annotation. Very rarely the description of what the data is like and how it was annotating has all the detail that is needed to redo it. The same applies to evaluation method and its settings. The description very rarely is the same as what was actually being done. And the same about the communication of the results is true. Is my cup half full or half empty? Depending on the author's culture and also if they are representing academia or industry, the storyline might change there a bit. From the very early ons of machine learning AI, some from 1980s are already these references that AI research should be driven by careful evaluation, and I fully support this statement. And evaluation should have not only the performance measurement, so for example, F1 score or AUC value, but it should also tell about the system behavior or method behavior as a whole, about its limitations, generalizability, and needs for future work. We need to know if the method is good, bad, or ugly, or what is good, what is bad, what is ugly, meaning success analysis and failure analysis. And in failure analysis, what are those severe issues that should really not be there? And what are more minor issues? This evaluation, careful evaluation, it's a cost, in particular in areas where, for example, clinicians who are highly trained and have other commitments, they are busy in their passion of looking after people. So hiring them to do annotations, that's quite costly, and one needs to take this one into account. One can use crowdsourcing for the same problem. However, there are ethical considerations as well as quality considerations to be made with respect to outsourcing the annotation work or evaluation work in this way. What one needs to know is intrinsic evaluation and extrinsic evaluation. So intrinsic means we evaluate every single component of the processing system in its isolation. So it could be, for example, the automated speech recognition component, and then the information of extraction of text classification component to fill out the form. And then we need also the extrinsic evaluation. So this goes back to talking to, in this case, the clinicians, or more generally, the users of the system, and asking their perceptions of what is needed to solve the problem, what are the current challenges, what isn't solved that well yet, do they find the solution useful or usable, or both? And this is usually alpha beta testing, so again, iterations, and iterations for improvement. I hinted earlier that there's an ethical code of conduct that we need to follow. So in evaluation, we quite often have the gold standard or reference standard formed by how well people do, how well people solve the problem. And in these cases, one needs to have appropriate ethics approvals and informed consent from the people involved in either the creation of the data or ownership of the data, as well as the annotation work. Usually one has to first have a plan and policy study, so know from a particular country or region what are the correct guidelines to follow. Then one needs to submit an ethics application, and when that's obtained, hopefully, if it's rejected, one needs to go back to beginning, but if one achieves it, we need to get informed consent from all the participants. Usually after that, there's a data collection and de-identification process. Sometimes the de-identification is not needed, but very, very rarely the data would be there ready to go just to be fed into the machine learning system in real life cases. My tip is also to have a look of repositories and hackathons and shared tasks for data sets that might be out there. Then there's the actual research time. And quite often in research, we notice that, okay, we need to do some revision to the data or the data collection procedure that we had, which means going back to the beginning again and doing the planning and policy study, getting the ethics approvals or amendments in place, getting the informed consent in place, gathering or annotating more data, perhaps de-identifying it. And finally, when the project ends, so the ethics approval is for a period of time for the research project, and all the participants need to be consented precisely for the research project that you have in your mind. In the end of that project, that data needs to be archived and or destroyed. So quite often in health projects, for example, what we do is that we return the data back to the hospital or healthcare jurisdiction where it originated from, and we destroy the data from all of the computers that we would have been using to conduct the research. And the best practice in ethical code of conduct is really, really important in machine learning projects. Where can we learn more? So here are a few tips. There are really good other crash courses. For example, in YouTube, there is the crash course for computer science. So the number 34, if I don't remember it wrong, is the machine learning and AI one. Then there's a specific one about computer vision, which is number 35. And the number 36 after that is natural language processing. And I have had a look of these myself, and I think that they are really good. If you want to get more, there are two really nice special issues of journals out there. So one by Science, and the other one is called The Great AI Awakening. These are from 2015 and 16. There's a very famous course from Stanford, MOOC, on Coursera, so massive open online course. This is the screen capture from the Coursera website just yesterday. So at the moment they are enrolling, and this is about a 6-week unit, and there's nice practice there incorporated with theoretical learning. So I really warmly recommend taking this after the hackathon. The tools go forward really, really quickly. At the moment in my group, a lot of us are using PyTorch, but there are other options out there too. PyTorch has most of the machine learning algorithms implemented. There's nice tutorials out there as well, how to get going. Also nice sample data sets so that one can practice quickly. If you want to learn more about the theory behind of these methods and the fundamentals of the methods, here are a few book recommendations. So on the left-hand side, these are more about the Bayesian approach to machine learning. So probability theory and that kind of things is the foundation to build on. And then there's the more statistical side, a couple of recommended books over there. And the bigger ones in the middle are the ones where I start to get going and then proceeding to the ones on the outer edges. And there's plenty of more reading available out there. Thank you so much for your attention. Please remember to pay careful attention to the envisioned use case and users of your technology. That's the #1 tip. So it's not only about the machines, but it's actually finding the right problems to solve and making sure that we provide value to the task. Have fun, work hard on your tasks. You will get there in the end. And here's a beautiful poem by Dr. Mark Nepo, which I think explains why this field of machine learning is so wonderful. So in order to make discoveries from data, actually just living through that problem solving, problem identification problem, or cascade, we normally get both the answer and the question from there. Good luck and have lots of fun. Bye-bye.